everyone, Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we're going to be looking at Section 7, Rates, Equilibrium and pH, and we're focusing in on how far.
Just work shoots are in.
So our outcomes for this session are to use the terms mole fraction and partial pressure to give expressions for Kc and Kp for homogeneous and heterogeneous equilibrium, to be able to calculate them and give them their units, and to describe the effect on equilibrium of temperature, pressure, concentration and addition of a catalyst. So, an introduction then. We spoke about this a little bit in the AS content, that a reversible reaction is one in which the reactant can go to the product, but the products can also go back to the reactant. And we said that we reach dynamic equilibrium when the concentration of each remains constant. A reversible arrow shows an equilibrium, and we can change the reaction conditions and shift the position of the equilibrium from left to right. So the equilibrium reactions rarely go to completion. Now here's a couple of definitions that you need to know for this section. Mole fraction is the number of moles of a specific component divided by the total number of moles present. And partial pressure is the pressure that a constituent species in a mixture would exert if it were isolated. The total pressure of a mixture of gases is the sum of all the partial pressures. Now, how can we use partial pressure? We need a quantity to express where the position of the equilibrium is, whether it's far to the left or far to the right, and we look at this reaction very often when we're speaking about our equilibrium constants. So we use the quantity Kp to analyse the position of the equilibrium, or we can use Kc. Now the C and the P, they're the same calculations, they're the same values. C just means concentration and P just means partial pressure. So they're calculated the same, it just depends on what reactants and products that we've got. So if the species are not in the gas phase, we will use an equilibrium constant, so Kc, for the aqueous species. We have two forms of equilibria: homogeneous, where everything is in the same phase, and heterogeneous, where they're in different phases and there could be a solid catalyst and reactants in solution. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link download to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye.